Good evening, dear students. So today we are going to start a new topic, that is thermodynamics. Okay. So, first let us see the synopsis. Okay. What do you mean by thermodynamics? Yes. What do you mean by thermodynamics? Anybody? So thermodynamics means what? It comes under what? It comes under physical chemistry. Okay. So you know that there are different branches of chemistry. Okay. Inorganic chemistry, organic chemistry, physical chemistry, pharmaceutical chemistry. Okay. So different branches of chemistry are there. So this thermodynamics, it comes under what? Physical chemistry. Okay. So what do you mean by thermodynamics? Yes. So it states what? It tells you what? It tells you the relation between different energies. Okay. Different forms of energy. So it tells you thermodynamics. Okay. It tells you about heat and different types of energies. Okay. So that is the thermodynamics. So it tells you, or it tells you about the different studies of processes. Okay. In which chemical energy is evolved. Okay, so it tells you what? It is a study of processes in which chemical energy is evolved. So there are two important things. Okay, surrounding and system. Okay, what is a system? System is a specific part. Okay, a specific part of a universe is called as a system, and surrounding is what? The rest of the universe. Okay, which is not a part of the system is called as your surrounding. Okay, now if I have to tell, okay, so this is your system. Suppose if I consider, okay, this small space as a system, leaving this small space, the rest, okay, so the rest is your surrounding. So this is your surrounding. Okay, so these are the two important things in the thermodynamics when you are studying the different processes. Okay, when you are studying the different processes. So it tells you about the system and surrounding. So system is what? It is a specific part, okay, in this universe, and the rest of the universe, okay, which is not the part of the system, is your surrounding. So there are different types of system, okay, isolated system, closed system, and open system. So these are the three different types of system. Isolated system is what? It is a system. First, we'll discuss about an open system. Okay, open system means it can exchange both energy and mass. Okay, it can exchange both. Open system, what it does, it can exchange both. Okay, that is the mass and energy with the surrounding. So what can be example of open system? Yes, anybody? What can be open system example? So open system, it can exchange both the mass as well as the energy. What can be an example of an open system? It can, if you take a vessel, okay, steam turbine, water in open beaker. Yes, very good. Now, if you take a vessel, okay, and keep water, okay, and heat it. So what will happen? There is both mass and energy, okay, it is exchanged, right? So this is an example of an open system. So your both your mass as well as energy is exchanged with the surrounding. So this is a open system. Closed system. What do you mean by closed system? Closed system means what? Closed system, it can exchange energy, not mass, with the surrounding. Okay, it can exchange what? It can exchange the energy and not the mass with the surrounding. It can exchange only what? It can exchange the energy. Okay, it can exchange the energy and not mass with the surrounding. It is called as the what? Isolated system. Okay, it is called as a closed system. So it can exchange energy and not mass. Only the energy can be exchanged with the surrounding. Then it is called as a closed. Isolated means what? It cannot exchange neither gas nor the energy. what can be example of isolated system? Thermoflask. Okay, thermoflask. So inside the thermoflask, if you keep water, okay, it will remain same as it is. So there, it does not change. Okay, it does not changes with the surrounding. So isolated system is what? It can exchange neither mass nor energy with the surrounding. So these are the three systems. Okay, so please remember the examples, very important. For example, for open system, closed system, and the isolated system. Okay, next. Properties. Okay, so there are different properties of a system: intensive properties and extensive properties. So what is intensive properties? It do not depend upon the quantity of matter. Okay, intensive property, it do not depend upon the quantity of matter. Okay, quantity of matter present in the system or size of the system. Okay, then it is called as the intensive property. So which are the different intensive properties, like your viscosity, density, surface tension? Okay, this comes under intensity property. It does not depend on the quantity of matter, okay, which is present in the system or the size of the system. What do you mean by extensive property? Extensive property depends upon the quantity. Okay, how much quantity of matter is present in that particular system? So extensive means it depends on the quantity of the matter what is present in the system. So what is the example? For example, the mass. Okay, mass, volume, and heat capacity. So these are the examples of extensive. So please remember the examples of intensive properties and extensive properties. What is intensive? It does not depend upon the quantity of matter. Extensive means what? It depends upon the quantity of matter. Okay. Next is state functions. Next is what? State functions. Properties which are used to define a particular thermodynamic state. Okay, so what are the state functions? It tells you, it defines the thermodynamic state of a particular property. Okay, then these are independent of path, okay, by which the state is attained. So these are the state functions. So what are the different state functions? Pressure, mass, composition, okay, volume, temperature, internal energy, entropy, and Gibbs free energy. So these are different state functions, okay, which will describe the particular thermodynamic state, okay, and these are independent of the path. Then what are the path functions? Okay, so these are the variables whose values depend upon the path which is followed by the system, okay, in attending that state. So these are the path functions. So these are the different definitions, okay. Then what is a thermodynamic processes? So there are different thermodynamic processes like isothermal, adiabatic, isobaric, and isochoric. Now what do you mean by isothermal? Heat is exchanged, okay. Heat is exchanged with the surrounding and the system, and it is not thermally isolated. So remember the definitions of what is the isothermal. Heat is exchanged. So isothermal means heat is exchanged between the system and the surrounding. Adiabatic process, no exchange of heat is taking place between the system and the surrounding. Okay, so no exchange of heat is taking place between the system and the surrounding. So it is called as what? Adiabatic process. Then isobaric process is what? Pressure is kept constant. Okay, where throughout the change, what is kept constant? The pressure is remaining constant. Then what is isochoric? Volume is kept constant. Okay, remember that isothermal, both heat and heat is exchanged with the system and the surrounding. Adiabatic means no exchange of heat is taking place between the system and the surrounding. Isobaric is what? Pressure is we keep pressure constant here, and in isochoric process, your volume is constant. Okay, so so it is dt is equals to 0 in terms of isothermal. dq is equals to 0, that is no exchange of heat is taking place, so it is dq is equals to 0. dp is equals to 0, that is pressure is kept constant, and dv is equals to 0, that is volume is kept constant. So thermodynamic processes, okay. Then cyclic process. What is cyclic process? A system undergoes a number of different processes and it will return to its initial state. So a cyclic process. So it will undergo different processes. Okay. And what will happen? At last, it will again come back to its initial state. So this is called as classic cyclic process. Reversible means what? process occurs infinitesimally slow. Okay, here, and opposing force is infinite smaller than the driving force. Okay, so here reversible process. So whatever has been moved forward, again it can be reversed back. Okay, so opposing force is acting. So how much the reaction is proceeding forward, okay, that much the reaction can reverse also. So opposing force is present, okay, so that will give rise to the reversible process. Irreversible means what? From initial it will go to final step. Okay, there cannot, this step cannot be reversed. So A will give you B only, B cannot give you A. So this is a what? This is a irreversible process. So it is from initial step it will go back to final step. Okay, it will not it cannot be reversed, it cannot be reversed. So this is a irreversible process. Then internal energy and internal energy change. Okay, so what do you mean by internal energy? So internal energy, it depends on what? It has a definite quantity of energy. Okay, it depends upon various factors like the chemical substance, chemical nature of the substance, temperature, pressure. Okay, so this will tell you about the internal energy. So internal energy, it is made up of kinetic energy and potential energy. Okay, so that is about the internal energy. Okay, so these were some of the definitions. Okay, now let us see few questions. Okay, how and how the this will come, questions will come like that. Let us solve the. Okay, so which of the following statement is correct? The pressure of reacting species in a covered beaker is an example of open system. There is exchange of energy as well as matter between the system and the surrounding is a closed system. The presence of reactants in a closed vessel made up of copper is an example of a closed system. D, the presence of reactants in a thermoflask or any other closed insulated vessel is an example of a closed system. So which of the following is the correct statement they have asked? So there are four statements given. So you have to tell which is among this, which is the correct statement. Yes, which is the correct statement? Which is the correct statement? So these are the examples of your open system, closed system, and isolated system. So apply the definition and the apply the definition and the examples and see which is the correct among the following, which is a correct statement among the following. So the presence of the reacting species in a covered beaker is an example of a open system. So there, what they have mentioned that it is covered. The beaker is covered, right? Now, if the beaker is covered, means what? There cannot be exchange of energy. So this is not a open system. Open system means what? Both the matter as well as the energy can be exchanged. So this is not the correct statement because it is covered. Okay. Then second, there is an exchange of energy as well as matter between the system and it is called as open closed system. No. Okay. When there is exchange of energy as well as the matter, then what we say, we call it as open system, right? We call it an open system. So this also statement is wrong. Then the presence of reactant in a closed vessel, which is made up of copper. Okay. Reactant is there in this. Okay. Something is there present in the copper vessel and you have closed it. So this is an example of a closed system. Yes. So in closed system, what is happening? There is a exchange of there is a okay, there is no exchange of this heat, right? Only okay, so only so this is the presence of, you can see here. So this is a correct statement. The presence of reactant in a thermoflask or any other closed insulated vessel is an example of closed system. No, it is an example of what? It is an example of isolated system. Okay, so which is the correct answer? Which is the Correct statement, it is option number C. Okay, Tejaswini understood? It is not B, it is C. B, what they have said, exchange of energy as well as matter between the system, it is in the surrounding, is a example of closed system. No, it is open system, right? So the answer is C. C, okay? Understood? Yes? Okay. Let us go for the next one. The state of a gas can be described by quoting the relationship between. So how the state of a gas can be described? How the state of the gas can be described? How the state of the gas can be described? So state functions for using the state of the functions, we will see what pressure, volume, temperature, and amount. Right? Pressure, volume, temperature, and amount. So these are the what? Pressure, volume, temperature, and amount. So these are the okay, by using these codes, okay, we can describe the state of the gas. So option number D is the answer. Okay, let us go for the next one. Adiabatic expansions of an ideal gas is accompanied by. Adiabatic expansions of an ideal gas is accompanied by. Adiabatic expansions of an ideal gas is accompanied by. So in adiabatic process, what is happening? In adiabatic process, what we can see in adiabatic process, it is accompanied by what? Just now we have discussed what is the adiabatic process. So no matter and no mass or heat transfer is taking place between the system and surrounding. That is your adiabatic process. So when you are seeing the adiabatic expansion of an ideal gas, okay, so that is given as, okay, so when you are seeing the adiabatic expansion of an ideal gas, so delta E is equals to, okay, change in energy is equals to delta Q minus W. Okay, so here whatever the work done is there. So for work done process, okay, so for an adiabatic process, we know that delta Q will be 0. So what does the negative sign indicates? The negative sign will indicate that there is a decrease in internal energy. Okay, so this internal energy which is showing the decrease, which is equal to what? Work done on the system by the surrounding. So what it shows? Decrease in delta E. So delta E is equals to minus W. Okay, so negative sign indicates that there is a decrease in delta E. Okay, work done on the system. So which so whatever the negative side, which is decrease in the internal energy, which is equal to the work done by the system on the surrounding. So option number A is the answer. Yes. Hema has answered. Tejaswini has answered. Murli has answered. Very good. Okay. Let us go for the next one. If a reaction involves only solids and liquids, which of the following is true? If a reaction involves solid and liquid, which of the following is true? Yes. If a reaction involves only solids and liquid, which of the following is true? So for solids, delta H, okay, enthalpy, change in enthalpy is given as delta E, that is change in energy, plus P into delta V. This is for solid and liquid, okay. So delta H is equals to delta E plus PV is equals to what? nRT, right? From ideal gas equation, we know that PV is equals to nRT. So we can also write delta nRT. Okay. So when delta N is equals to 0. Okay. So where delta N is equals to 0. So if a reaction involves only solids and liquids, which is the answer? It is option number D. Okay, so delta H, that is change in enthalpy, is equals to delta E plus P delta V. Okay, so we know that PV is equals to nRT. So after substituting that, we are going to get this. So option number D is the answer. Option number D. Okay, fine. The molar heat capacity of water at constant pressure is 75 joules per Kelvin per mole. When 1 kilojoules of heat is supplied to 100 grams of water, which is free to expand, the increase in temperature of water is. So what all is given here? Molar heat capacity is given of water, which is 75 joule per Kelvin per mole. Okay. Then what is given? When 1 kilojoules of heat is supplied to 100 grams of water, okay, which is free to expand, the increase in temperature of water is. So find the number of moles. Given mass of water is 100 upon what is the molecular mass is 18. So this is the number of moles of water. Okay. Then this is given how much heat is supplied, 1 kilojoules. 1 kilojoules, if you want to convert it into joules, so it will be 1000 joules. Okay, so what you have to find? You have to find the expand the increase in temperature. So delta T, find out the delta T. Okay, so the formula is Q is equals to N Cp delta T. Okay, so delta T is equals to what? Delta T is equals to Q into N Q divided by delta T is equals to Q divided by NCP. Okay, use this formula, substitute now to find the increase in temperature of water. So Q is equals to 1000, N is equals to 100 by 18. So this will become 100, okay, and by 18. So this will be reverse, okay, because it is coming in the denominator. Then into CP is 75. Substitute and see what will be the answer. What you are getting? Okay. Option number C. Yes, very good. 2.4 Kelvin. Okay, so after substituting, you are going to get the increase in temperature. So remember, if the question is asked, okay, on the molar heat capacity, so if they have asked to find out the increase in temperature, okay, so that can be used. So this is a formula which has to be used. Okay. Considering entropy as a thermodynamic parameter, the criterion for the spontaneity of any process is. So entropy. What is entropy? Entropy is nothing but randomness, right? Randomness. What is entropy? Entropy is nothing but the randomness in the system, right? Randomness on the system. So now here, considering the entropy as a thermodynamic parameter, the criterion for the spontaneity of any process is. So remember that for any spontaneous process, okay, entropy, okay, that is delta S, the total entropy on the system, it will be always positive. Okay, it will be always positive. So it is option number A. So the total entropy on the system plus the surrounding, it will be always positive. Okay, so option number A is the answer. Yes, very good. Identify the correct statement for change of Gibbs energy for a system, delta G system at a constant temperature and pressure. Considering, identify the correct statement for change of Gibbs energy for a system at constant temperature and pressure. Gibbs energy for a system at constant temperature and pressure. Gibbs energy. Identify the correct statement for change of Gibbs energy for a system at constant temperature and pressure. Yes, read the uh, read the options. If delta G of the system is equals to 0, the system has attained equilibrium. Delta G of the system is 0, the system is still moving in a particular direction. If delta G of the system is less than 0, the process is not spontaneous. If delta G of the system is greater than 0, the process is not spontaneous. Okay, Murli has answered as A. So what is Gibbs free energy is used for? To calculate the maximum amount of work, right? It is used. So when we see the Gibbs energy, so delta G, okay, delta G of the system, okay. So at a constant temperature and pressure, it will be what? The system has attained equilibrium. Yes, option number A. So if the delta G of a system is 0, that means the system has attained equilibrium. So option number A is the answer. Okay. So first law of thermodynamics, let us just read. Okay. So first law of thermodynamics is what? It is based on the conservation of energy. That is, energy can neither be created nor be destroyed. The total energy of the universe is constant. The mass and energy of an isolated system remains constant. The total energy of a system and its surrounding, it must remain constant. Okay. Although it may be changed from one form to another. So this is with respect to first law of thermodynamics. So if the work is done on the system, okay, to attain the change, so according to, so it will be first law of thermodynamics, heat absorbed by the system will be equal to increase in the internal energy minus the work done on the system. So we had seen this question, right? Q is equals to, that is delta E minus W, or delta E is equals to Q plus W. Okay, so what does it represent? It represents the mathematically the first law of thermodynamics. Okay, so this is about the, so remember this particular equation. Okay, important. So that is first law of thermodynamics, that is heat absorbed by the system will be equal to increase in its internal energy minus the work done on the system. So then enthalpy and enthalpy change. Okay, what is enthalpy? It is defined as the sum of the internal energy and the product of its pressure and volume. So this also we have seen, that is enthalpy is equals to E plus PV, right? So just now we have seen that. That is, so enthalpy is also called as the heat content. That is delta H is equals to delta E plus P delta V. So that is delta H is equals to delta E plus nRT, right? Why? Because PV is equals to nRT. So this also particular question we have seen. Okay, enthalpy and enthalpy change, how it is determined. Okay, so internal energy and the product of the pressure and its volume. Okay, so this is about the enthalpy of the system. So remember these equations. Okay, then heat capacity. So what is heat capacity? Amount of the heat needed to raise the temperature of a given substance by 1 degree Celsius, right? So that is Q is equals to delta T. So heat capacity. So it was, so here, so Q is equals to C delta T. Okay. So if the temperature of the substance, it is changing from T1 to T2, then heat required will be Q is equals to C into delta T. Delta T is change in temperature. Okay. From T1 to T2. So that is difference of delta T. How it is taken? If you give delta T, it is T2 minus T1. Okay. So heat capacity. So it is the amount of heat which is needed to raise the temperature of a given substance by 1 degree Celsius or 1 degree Kelvin. Okay. So this is about heat capacity. So this formula you remember. Okay. So heat capacity, it is directly proportional to the amount of substance. Okay. And molar heat capacity of the substance is what? It is molar means it is related to 1 mole of a substance. Okay. So Cp is given as the delta H by delta T, where P is constant, and Cv is equals to delta E by delta T, where volume is constant. Okay. And Cp minus Cv is equals to Nr. Okay. So these three equations also please keep in the mind. Then heat of combustion. Just read once. What is heat of reaction, heat of formation, heat of combustion, heat of solution, heat of neutralization, heat of fusion, heat of vaporization, heat of sublimation. Okay. Then Hess law, very important. Okay. Based on this, Hess law is very important. Then spontaneous and non-spontaneous reactions. Okay. So a process which has a natural tendency to occur either of its own. Okay, then it is called as spontaneous reaction. Spontaneous process means this process, it undergoes its own. Okay, and it has a natural tendency. Non-spontaneous means it does not has the natural tendency. Okay, so it is called as a non-spontaneous reaction. For example of spontaneous reaction, suppose you take a beaker. Okay, in that beaker take water and add salt. Okay, without the help of spoon also, the salt will get dissolved in the water. So this is an example of a spontaneous reaction. Now take a beaker. Okay, add a gold. Okay, add a gold and in water. Okay, will it get dissolved? Gold will get dissolved in water? No. So this is a non-spontaneous reaction or process. Okay, because it does not, gold does not have that natural tendency to get dissolved. Okay, so these are the examples. So remember the examples, very important. Entropy, okay, it is a randomness. Okay, it is a measure of randomness or disorder of the molecules in a system, right? So then second law of thermodynamics, the entropy of the universe is continuously increasing, or heat cannot flow of its own from colder to hotter region. So yes, so just now we have seen this delta S of universe. Okay, change in enthalpy is equals to delta S of system plus delta S of surrounding, which is equal to 0 for a reversible process. And for a non-reversible process, it is what? It is greater than 0. So, okay. So this is also, so this is on second law of thermodynamics. So it tells it is based on the entropy. Okay, it is based on the entropy. Then Gibbs free energy. What did we say? Gibbs free energy. It is the amount of energy which is available from a system that can be used, okay, for a useful work, which can be put forth for a useful work. How is entropy? Gibbs free energy given as G is equals to H minus Ts, where H is the change in enthalpy, S is the entropy, T is the temperature in Kelvin. Okay. So this also we have seen. So this particular table, very important. When change in enthalpy is negative, change in entropy is positive. Okay. Delta G, change in Gibbs energy is negative, spontaneous at all temperature. Okay. So these all things, please remember, very important. So just keep this tabular in mind. Okay. Next is the third law of thermodynamics. So at absolute zero temperature, the entropy of a perfectly crystalline substance is taken as zero. So this is your third law of thermodynamics. Okay. So these are the things, okay, from this particular chapter. So let us see the remaining questions. Okay. What is the correct statement regarding entropy? Yes. What is the correct statement regarding entropy? Yes. What is the correct statement regarding entropy? At absolute zero temperature, entropy of a perfectly crystalline substance is taken to be zero, right? Then, so this is what? This is the third law, this, right? So this is the, when you are at absolute zero temperature, the entropy of a is taken as zero. So this is the correct statement. So this is the third law of thermodynamics, which is based on the entropy of a system, okay, which talks about the perfectly crystalline substance when it is taken as zero. So at zero temperature, entropy of a perfectly crystalline is taken as zero. So this is correct regarding the entropy. So just now we have seen regarding the third law of thermodynamics. Okay. A chemical reaction will be spontaneous if it is accompanied by a decrease of. So when the chemical reaction will be spontaneous if it is accompanied by a decrease of what? Entropy of a system, enthalpy of a system, internal energy of a system, or free energy of a system. So this is from that chart. Okay, I had showed you the chart. No, from that it is. So chemical energy or reaction, it will be spontaneous. Okay, if free energy of a system. Okay, if there is a decrease in free energy of a system. So whenever a chemical reaction, okay, it will undergo. It has a natural tendency, okay, for a reaction to proceed when when it is accompanied by a decrease in free energy of a system. So for this reaction at constant temperature, delta H minus delta E is. So find out this. So for a reaction is given. You have to find what? Delta H minus delta E. Okay. At constant temperature. So temperature is kept constant. Okay, temperature is kept constant. So delta H is equals to delta E, okay, plus delta nRT. So this is based on the next. What all is given? Delta N is given. Delta N. Delta N is equals to number of moles of gas 3 minus 1 plus 5. Okay, so it will be 3 minus 6, which is equals to minus 3. So delta H minus delta E is what? Minus 3 RT. So it is option number C. Option number C. So N is what? So for the reaction at constant temperature where delta H minus delta E is. So delta H minus delta E, we have to find delta H minus delta E. So by formula, we know that delta H is equals to delta E plus delta N RT. So let us find delta N, that is 3. Okay, 3 minus 1 minus 5. Okay, 1 plus 5. So that is how much? Okay, you are going to get minus 3. So delta H minus delta E, which is equals to minus 3 RT. So it is option number C. Option number C is the answer. Which of the following are not state functions? Yes, which of the following are not state functions? Q plus W, Q, W, H minus TS. Yes, which of the following are not the state functions? Heat and work. Okay, they are not state functions. When you have Q separately and W, heat and work separately, they are not wave state functions, but heat plus work is a state function. Okay, so H minus Ts, this is also a state function. So which is the correct answer? Which is not a state function. So 2 and 3. 2 and 3 means option number D. Option number D. So 2 and 3, okay, these are not the state function. Uh, your heat plus work is a state function. H minus Ts is also a state function. But heat separately and work done is not a state function. Got it? Okay. So these were some of the questions. Okay. Any doubts up to here? So thermodynamics. Okay. Few more questions. We will see in the next class. Any doubts up to here? Okay. Fine. Okay. Fine. So I'll end this session here. Okay. So we'll meet in the next class. So we'll continue with the same topic, thermodynamics, in the next class also. I hope you have understood. Okay. If you find some more questions on this chapter, please solve them. Try to solve them. Okay. So we'll meet in the next week. Thank you.